Today we're going to talk about storage innovations for VMware Horizon View. The first topic we're going to cover is the link clone. The VMware link clone has a Delta file, and that Delta file uses a 512 byte grain size for all the writes that go to the individual virtual machine. This is based on a VMware snapshot, and it's problematic to storage vendors that don't have a 512 byte block size. This is an issue because writes then become partial in that they are spanning the file system block boundaries. And so thus scalability is ultimately decreased because we are having to do more I/O than is actually being requested from the guest. So visually, when somebody does a write of a 512 byte block, then a 4K write, and then a 1K write, what ends up happening on the storage is that we are having to span the underlying block boundaries on the guest, from the guest down to the actual storage. And so this causes overhead when trying to write in anything outside of that 4K boundary. VMware has come up with an SESPARSE disk format, which is based on a vSphere 5.1 using Horizon 5.2, and it works for native link clones only. So this disk format will support the creation of virtual machines using Hypervisor snapshots that's based on a 4K grain. And so what ends up happening is this allows us to be able to do a bunch of things. Reduced I/O from the desktop itself, as well as to be able to do space reclamation within the virtual machine to gain back space. So if we take a look at our two examples and how this differs with the 512 byte grain size, when I/Os happen, they happen now along those 4K boundaries, and so we don't have to do additional I/O to when you break up a block across the block boundaries. And so the next thing we're going to talk about the impact of cloning. Anytime a customer makes a decision to choose a cloning method, whether it be full desktops, whether it be native link clones, there is a scalability issue that can happen based on the cloning method that you actually select. And so what we're going to talk to you today is about all storage, not just shared storage. This is including DAS as well. Cloning has a cost, and selecting the cloning method that fits your particular workload and your use case is important, and understanding the impacts to storage so that we can try to architect a solution that avoids those particular issues. So we're going to take the example here of a hypervisor clone, and this is true for any hypervisor that uses snapshots as the underlying method for cloning. We're going to take the virtual machine, and the virtual machine really consists of two parts. The two parts are the OS disk, or the Delta file, and the replica disk, which is the C drive, which is shared amongst all the virtual machines. When we do a read from the OS disk or from the guest, we end up having to read metadata, and then we actually do the read of the data block itself. So this means that every one read from the guest operating system is two reads to storage. And the same thing holds true for writes. When we do a write, we actually have to do a write from the VM to the OS disk for metadata. We have to do a metadata read and a metadata write, as well as the data write. So we're now having to do three I/Os for every storage, three storage I/Os for every one guest I/O. So, and of course these blocks are very small in the metadata reads and writes, but it adds additional I/O to the infrastructure. So this is true for any storage, including DAS. And so this is why we see a lot of flash in the marketplace trying to alleviate and avoid the problems that are associated with creating hypervisor-based clones. So if we look at an example and break it down, if I have a 20% read workload at 80% writes and a 10 IOP desktop, what ends up happening is we end up having 4 reads from those 2 IOPs that were for reads, and we end up having up to 16 writes and 8 reads for each individual I/O. So what we end up getting is a multiplier of 2.8 times. So for every 10 guest IOPS, we have 28 storage IOs. And so this is inefficiency, and it's seen in this graph here, right? This is a virtual machine that's running. We see it's a 1-to-1 ratio between the number of IOs and from the guest to the storage. And when we take a hypervisor snapshot, immediately we see this inefficiency happen. So in the blue line is the VM IO, the number of IOs that the VM is actively doing, and the number of storage IOs are almost like 2/3 of the total number of IOs. So we have this inefficiency here between what the guest is doing and what the storage is doing. And we see there's a huge drop in the total number of IOPS that are being done during that time. And this is for new writes. When we get into an overwrite behavior, we start to have issues with, now we're overwriting blocks that may, and this was done with the Delta disk prior to the SESPARSE. We have an inefficiency here. While we are able to do more IOs because we are not having to do that metadata write, we still see this inefficiency across the board. So what are we recommending today, right? Today, in a VMware View environment for full clones, we recommend using a storage controller that allows you to be able to offload the creation of the clone in hopefully a deduplicated method and be able to do staggered patching practices, do things smarter within the guest operating systems. And then for non-persistent, right now there's not a technology that's available in the marketplace that's supported that provides this functionality to offload this I/O. But what we can do is we can use the SESPARSE disk format, which will provide us some overhead. But we actually have a technology that VMware is working on with the storage partners to be able to offload the cloning capabilities to the storage so that we can help reduce the cost of these solutions, not have this metadata read and write penalties, and it can all be managed by the connection broker. So, and again, this is using VAI, so it's for persistent or non-persistent. And this is called VCAI. And so all the reads and writes are now a 1-to-1 relationship between the storage and the guest. So we don't have an overhead with reading and writing the metadata associated with native link clones. So as you can see, we have done a comparison between VCAI versus a Delta disk that was fully populated. Again, you could see that there's so much more overhead in the number of ops that these 100 machines were doing, and this discrepancy here is due to the overhead in maintaining the metadata. So what our recommendations will look like in the future are going to be, for non-persistent desktops, offload to VCAI so that you don't have to pay that initial, that metadata performance impact. And so we're going to show a quick demo here of using VCAI. And so what we're going to do is just log into VMware View, Horizon View, and we're going to create a pool of desktops using VCAI. And the nice thing about VCAI is that now we don't have to change our workflows and use things like the rapid cloning utilities. We're able to use the desktop workflows as they were intended and be able to benefit from the storage integrations. So we're going to create a floating desktop pool, and we're going to use native link clones here. Type in the pool ID. We're just going to accept the defaults on all these selections here. Type in the name, the pattern of the virtual machines, and we're going to create 5 desktops or 10 desktops. And so the only real difference is after and for this demo actually we're not going to use disposable files for the purpose of demonstration. We'll select the parent VMs that we're going to use for VCAI. We select that snapshot. Choose where it goes. The host or cluster that is we're going to provision to. Resource pool. And then the data store. So for VCAI, it's an NFS feature today, and it requires that the storage controller support VCAI as well as the VIB is installed within the ESX hosts that is going to be provisioning to. Then we're going to click here. We're going to select the use NFS snapshot VAAI instead of reclaim space. And this is basically all you need to do to be able to create clones utilizing VCAI. Is selecting the box to offload the storage, offload the cloning operation to the storage. So thank you for the opportunity to speak at the Brown Bag, and I hope you've enjoyed the session.